Hi, my name is Matt Benoit. I'm the Director of Public Works for Tellico Village, and the last presentation we're going to offer you is on the topic of odor control. So when we talk about odor control, we need to understand a little bit about what happens in the grinder pumps in our yards. So here's the process, and I've got a hand-drawn diagram on the right. Liquids and solids enter the tank from the 4-inch lateral leaving the house. Since the liquids are lighter, they'll naturally get pumped first. The solids kind of have to get saturated with the liquids until they can be pumped, so they stay in the tank longer. There are several different sizes of tanks throughout the system. We have 1,000-gallon tanks, 750-gallon tanks, 380-gallon tanks, but the majority of the tanks are in the 1,000-gallon variety. The float switch in the tank is set to empty the tank at about a 60% capacity. As a general rule of thumb, consumers use about 100 gallons a day of water per person in the household. So for a two-person household, the pump probably discharges the liquids and whatever solids have been saturated about every 3 days. But the solids will remain much longer until they become saturated. In a closed system, there's a chemical reaction when those solids sit and deteriorate that generate odor. So our odor control problem starts really early. The gas that's generated is hydrogen sulfide, H2S. H2S is colorless and has a distinct rotten egg smell. It's dangerous. At a concentration of 100 parts per million by volume, the sense of smell can be lost. At a concentration of 500 to 700 parts per million per volume, especially in confined spaces, a human can lose consciousness or even death can occur. It's also highly flammable and explosive. Recall from a previous presentation some pictures of the wastewater pumping station. This is the air scrubber at Kahiti. Note the presence of electrical and mechanical controls at the site. The air scrubber continually pulls and filters the H2S out of the pumping station wet well to prevent the flammable and explosive properties from the H2S from interacting. Within the air scrubber, we filter the H2S with carbon filters. Carbon filters work well, but they don't tell you when they're used up. They also treat H2S at a rate of significant deterioration. So the more H2S that's in there, the faster the carbon will expire. And so part of the reason we get odor complaints is because we change the filters on a regular basis, but depending on how much H2S is in the system, sometimes those carbon filters will last 2 weeks, sometimes a month, sometimes 45 days, but they don't alert you to the fact that they've lost their carbon properties or been expended. And that's why we a lot of times encounter odor complaints. So do we have an odor control problem? Yes, and a lot of you probably knew the answer to that question. So Tellico Village employed Jacobs Engineering to conduct an odor control assessment in December, and we received the results in March. So how are odor control studies conducted? At the lift stations and problem areas where we have air release valves within the system, air samples were conducted, grabbed, and analyzed at 9 locations, including Kahiti. As we look at the results on the next slide, keep in mind the typical goal for mitigating odor in a wastewater system is somewhere between 5 to 10 parts per million by volume, with peaks no higher than 50. So again, keeping in mind where we're trying to head, this chart illustrates what the grab samples are. And really only at the Mialakwa pumping station are we at an industry standard level that you would say to yourself you don't have an odor problem. Now there is one difficulty with the data we're dealing with, and that is that warmer temperatures accelerate the chemical process generating H2S. So when you're looking at these figures, keep in mind January to February sampling will likely be the best case scenario for what you will see in terms of H2S at these sampling locations. And notice there is a correlation between those pumping stations that lack adequate capacity that we discussed in a previous presentation and the higher both H2S on an average basis and in recorded maximums also correlate. So these pumping stations that lack capacity also have greater odor. Same's the case for Mitigation, which we discussed is oversized and has far less odor control complaints. So what do we do to mitigate odor control problems? There are three ways to address this issue. There's the vapor phase treatment, and this approach attempts to enhance the size and capability of the air scrubbers that we looked at pictures of at the pumping stations. So you're trying to catch it before it releases out. A liquid phase treatment attempts to chemically dose the wastewater while it's still in the wastewater pipes to mitigate the presence of H2S before it gets to the pumping stations. The third is both. And if you're like me, you're thinking, let's do both. Well, let's talk a little bit about what that means. 6 vapor phase systems. So that would be one installed at Mitigation, Tennessee Shores, Tennessee Cove, Tokwa pumping station, the main pumping station, and the Kahidi pumping station. These vapor phase systems would be better and more comprehensive, transitioning just from carbon to something called biotrickling and then carbon polishing. So we'd be working away from those filters. For these systems, the capital cost for 6 vapor phase systems is estimated at $4.9 million. That's not 4.9 per pump station, it's 4.9 in total for 6 of them. And operations and maintenance cost is estimated at about $72,000 annually. Sized and implemented correctly, these systems will aim to reduce the H2S in the system by 99%, or put us in the range of 0.5 parts per million by volume. Liquid phase treatment costs aren't cheap either. The liquid phase treatment attempts to address the wastewater after it's left the household wastewater tanks, but before the wastewater travels very far. Early in the wastewater journey likely means attempting to introduce liquid phase at the Mitigation pump station and the Tennessee Cove pump station. At these pumping stations, chemicals such as calcium nitrate, hydrogen peroxide, or magnesium hydroxide are all candidates. For a number of different reasons, calcium nitrate appears to be the best approach. To begin injecting calcium nitrate at these pumping stations, the estimated costs presume an annual chemical cost of about $90,000 combined for 2 pumping stations, an estimated capital cost in the neighborhood of $861,000 for 2 pumping stations. The difficulty is the outcome of this approach isn't as clear as the vapor phase. It'll require some testing and some babysitting of the system to determine the correct dosage and ensure that what you're putting upstream is having a negligible effect at the next pumping station. So I just illustrated a chart and broke them down both by estimated capital cost and estimated annual operating cost, just to illustrate if you're thinking about doing both, which is a good comprehensive solution. You're talking about something in the neighborhood of about $5.7 million capital cost to install these features, and about another $160,000 a year, both to make available the vapor phase components, which still has some technologies and some components that will need to be replaced, as well as the chemicals that are introduced at the liquid phase treatment. So there is a balance. Liquid phase treatment will reduce the presence of H2S at downstream pumping stations and at those air release valves. But consider all of this equipment, chemicals, and refined dosing. That's going to be new to us. We'll get there with the liquid phase. But whatever the liquid phase accomplishes will limit the extent of odor that needs to be treated at the vapor phase. There's a conceivable solution that relies on 2 liquid phasing stations, probably at those same 2 pump stations, and a vapor phase solution consisting of 4 instead of 6. That reduces the capital cost by about $700,000, lowering it from about 4.9 to 4.2. Annual operating and maintenance costs are about the same. So really, even trying to do something of a hybrid approach doesn't really do it. You sort of need to make up your mind, am I going to rely exclusively on the vapor phase? Am I going to rely exclusively on the liquid phase, which will have lower costs? Or am I going to try to do with a comprehensive solution which carries with it some fairly significant costs? So as it relates to odor control, some obvious questions. Is inflow and infiltration sort of helpful? Yeah. Unfortunately, the only mechanism available to dewater or clean out those household tanks is really inflow and infiltration. It has the effect of diluting the solids and moving the wastewater. So if inflow and infiltration assists with odor control, should we all stick a hose down in our household tanks and fill it up with water a few times a week? My answer to that is please don't do that. Inflow and infiltration introduces more problems in the long run than the limited benefit associated with odor control. Another question is there something residents can put in their household tanks that will assist with the liquid phase, i.e. knock down the H2S in the household tanks? Again, please don't do that. First, please don't open those lids. It stinks really bad, and I really don't want you to have that experience. But furthermore, the odor control study that Jacobs provided goes into great depth about the liquid phase chemicals available on the market. Some can cause corrosion in the pumps and the electrical components, both at the household level and at the pumping station. So while they may have some nominal effect related to the H2S, it can be harmful to the equipment. Some might not work in the magnitude of the issue we're talking about in Tellico Village. If you refer back to that chart that I showed you, there isn't really a circumstance where we don't have a significantly measurable odor control problem. And so figuring out how much of what to put in there would be very, very, very difficult to determine whether it's working at all. The bottom line is, without testing and monitoring, this whole issue of attempting to introduce something into your household tanks could very well cause more problems than it solves. Odor control implementation isn't simple. Recall the picture back on slide 20 of the air scrubber at Kahidi. Kahidi Neighborhood Pumping Station will be remodeled, and the pumping station itself may or may not sit precisely where it does now, in which case a newly installed air scrubber on the old pumping station for chemical dosing may end up in the wrong place. These parts and components are too expensive to build twice. So more study and consideration needs to be given to how to align neighborhood pumping station renovations with odor control. Odor control can go first, no question about that. But there's a risk that by constructing these odor control facilities, we may end up doing it twice once the neighborhood pumping station is remodeled or replaced. On the other hand, the odor problem is clearly present now and may not be feasible to delay to catch up with the neighborhood pumping stations. So that's an issue because of the fact that we're in the master plan level that we need to study and consider our options. This issue will get sorted out. It'll be vetted by your Public Services Advisory Committee, your Finance Committee, and the Board of Directors. Thank you again for considering this presentation on odor control. Can't see you, but I think you've been a very delightful audience, and this does conclude all of my presentations. Thank you for your consideration.